Right, now we're going to talk about prime factorization. In the last video, we talked about prime numbers. A number is prime if it's not 1. 1 is not a prime number. And the only numbers that go into this number is 1 and the number itself. For example, 9 is not prime. Yes, 1 goes into 9 evenly, and 9 also goes into 9 evenly. That's always going to happen. A number, 1 goes into every number, and the number itself goes into the number one time. But you know what? There's other numbers other than 1 and 9 that go into 9, like 3. 9 is not prime. But you know what? The only numbers that go into 7 is 1 and 7 goes into 7, the number itself. Nothing else goes into 7. 7 is prime. 9 is said to be not prime. 9 is not prime. It's called composite. But that's for the next video. So now, given a number, the last video, excuse me, given a number, we want to write it as a product of prime numbers. And that's what prime factorization is. Given a number, say the number 6, write 6 as a product of prime numbers. Well, 6 is 2 times 3, and 2 and 3 are prime. 50, for example, I know 50 is 2 times 25. Well, 2 is prime, but 25 is not. 25 I can write as 5 times 5, and all of those numbers are prime. We can also say that 5 times 5 is 5 squared. But please don't forget the 2. Number 18, for example. 18 you may recognize as 6 times 3. But 6 is not prime. 6 is 2 times 3 times 3. Those 3 numbers, they're prime. Those 3 numbers are prime. But since we have 3 twice, I can say 2 times 3 squared. Or I could have recognized 18 as 2 times 9. 2 is prime. It stays. But 9, that's 3 times 3. And those 3's are prime. Well, we get the same answer. 2 times 3 squared. The way you get the prime factorization is not necessarily unique. For example, if you did it this way or that way, they're not the same way. In the first problem, we never talked about 9. In the second problem, we never talked about 3 at the beginning. We never talked about 6. But you know what? We got the same answer. Prime factorization is unique. If 2 students write 18 as a prime factorization, as a product of prime numbers, they'll get the same answer, 2 times 3 squared. Now you may say, boy, this guy's good at this. Is there an algorithm to get this? The answer is yes. You use a tree diagram. You have 60. Can you think of 2 numbers and multiply out to 60? Well, let's do it twice. One student may say, yep, 10 times 6. Another student may say 20 times 3. Yet another student, so doing it 3 times, might say 15 times 4. Okay? But now 10 is 2 times 5, and 6 is 3 times 2, and that's it. You can't break down the 2. You can't break down the 5 anymore because they're prime. The same with the 3 and the 2. So the answer will be 2 times 2 times 5 times 3 is 2 squared times 5 times 3. And you can check it. This is 4 times 5 is 20 times 3 is 60. Okay, now let's do the middle one. 3 is prime. We're done. Now 20. Here we have an option. Maybe a few options. 20 is 2 times 10 or 4 times 5. You pick one of them. 5 times 4. 5 is prime, but 4 is not. 4 is 2 times 2. Now, here's a major comment. The 2's are prime, so we circle them. The major comment is this tree diagram was very helpful in finding the prime factorization of 60. But the prime factorization of 60 is a product of prime numbers that multiply out to 60. So you need to say it. Well, 2 times 2 is 2 squared times 3 times 5. Here is the answer. 2 squared times 3 times 5. The tree diagram helped us greatly, but nonetheless the answer is 2 squared times 3 times 5. The instructions are to write each number in prime factorization form. And each number is 6 and 50 and 18 and 60, etc. Let's do a couple more of these. Suppose you have 296. You have the number 296. First you should realize, well, it's even, so 2 goes into it. And 2 into 296 is 148. 2 is prime. If you didn't know that, you do long division. 2 into 296, 1, no remainder 4. 2 into 9 is 4, remainder 1. 2 into 16 is 8. 148. Then you should say, oh, 148 is even. Unless you see a larger number. You don't only have to do 2. If you see a large number, go for it. If you realize 12 goes in there, divide by 12. That is, do 12 times whatever. But 12 doesn't seem to go into it. But 2 does. I think so. Does 4. If you saw that, that's good. Okay, so 2 goes in here 74 times, and 2 is prime. 74 is even. The largest number that goes into 74 is 37. Goes in 2 times. 74 is 2 times 37, and no number other than 1 or 37 goes into 37. 2 doesn't go into any odd number. 4 doesn't go into an odd number. No even numbers. So you try odd. 3, 5, 7, 9, 11, etc. They won't go in there. If you think about it, you don't have to go past 7. Okay, excuse me. The prime, I was going to say, that is the prime factorization of 296. But no, it's not. The prime factorization of 296 is 2 times 2 times 2, 2 cubed, times 37. 2 cubed is 8. What do you think 8 times 37 is? Okay, you have to understand what equal means. 296, we claim equals 8 times 37. So you can check your answer, make sure that it checks. 8 times 3 is what, 24 plus 5? It's 29. 296, this number. The only way this can be wrong is if 2 wasn't prime or 37 wasn't prime. But they both are. Okay, let's try one more, at least. Suppose you have the number 300. Suppose you have 300. Well, one may say this 300 is 10 times 30 or 100 times 3. 10 times 30. Whatever you say, it's up to you. Just don't say 1 in 300. Okay, 10 is not prime. 10 can be broken down to 2 times 5. Both of which are prime. Like when you break down 30, don't say 1 in 30. Because then you're going to have to break down 30 anyways. You didn't get anywhere if you do that. But what you could say is 5 times 6. You could say 5 times 6 is 30. Or 10 times 3. Now 5 is prime, but 6 is not. 6 becomes 3 times 2. And both of these are prime numbers, so we're done. 300 is 2 times another 2, or 2 squared, times 5 times 5, which is 5 squared, times 3. The order you write these numbers is up to you. You could say that the answer is 2 squared times 3 times 5 squared, or you can say it's 3 times 2 squared times 5 squared. There's actually 6 different ways. It doesn't matter. It doesn't matter. Okay. What does matter is that you know how to find the prime factorization of numbers, and hopefully you understood it, because this section is now over. Good luck with it. Thank you.